Welcome to doassignment-ca. Here is the problem. A particle has velocity v equals 6t minus 3t squared in meters per second. The position s equals 0 when t equals 0. At t equals 3 seconds, find 1, the deceleration or acceleration, 2, the position s, 3, the total distance traveled, and 4, the average speed. Now let us work through the solution step by step. Acceleration is found by differentiating the velocity function with respect to time. Differentiating gives a equals 6 minus 6t. At t equals 3 seconds, a equals 6 minus 18, which equals negative 12 meters per second squared. The negative sign means the particle is decelerating. To find position, we integrate the velocity function. Integrating gives s equals 3t squared minus t cubed plus a constant c. Applying the initial condition gives c equals 0, so s equals 3t squared minus t cubed. At t equals 3 seconds, s equals 27 minus 27, which equals 0 meters. The particle has returned to its starting point. Because the particle might reverse direction, we find when velocity equals 0. Setting 3t times 2 minus t equal to 0 gives t equals 0 and t equals 2 seconds. The particle reverses direction at t equals 2 seconds. The position at t equals 0 is 0 meters, at t equals 2 is 4 meters, and at t equals 3 is 0 meters. Total distance equals the absolute value of 4 minus 0 plus the absolute value of 0 minus 4, giving 4 plus 4 equals 8 meters. Average speed equals total distance divided by total time, which is 8 divided by 3, approximately 2.67 meters per second. To summarize, the acceleration at 3 seconds is negative 12 meters per second squared, indicating deceleration. The position is 0 meters. The particle returned to the start. The total distance traveled is 8 meters. The average speed is 8/3, approximately 2.67 meters per second. Visit doassignment.ca for more study tools, AI learning support, and online tutoring.